Well, I bought another vintage tube amplifier. This one was such a great deal that I really couldn't pass it up. It is a Silvertone model 1432, which was made either somewhere between 1959 and 1961. I'll have to check the date codes to find out exactly what year this one is. And it is, of course, Silvertone was the Simpson Sears model. Sears Roebuck in the States, and it actually has tremolo. It's a 6v6 push-pull amplifier, and it's very unusual in that it has a preamp section up here. The control and preamp section is up here, and then of course the tremolo circuit and the power amp is down here. They're connected by a wire. So this one, the gentleman who sold it to me said that it was in his father's basement for quite a while. And I can tell that from the dust and from the rust on the transformer. So it's obviously going to need some work. I'm going to have to replace the electrolytics, I'm sure. I haven't even turned it on yet to test it. But we'll do that on a Variac with the current limiter. Well, you can see there's quite a bit of dust and rust. So we'll clean that up. See what happens. So it has the original speaker. Well, the speaker code appears to be the 37th week of 1959. And these are original Silvertone tubes, and I see that this one is dated, I think that's the 9th week of 1960. So this is probably an early 1960 amplifier. And here is the 1960 catalog entry for the Silvertone 1432, which costs $67.95 at the time, and you could buy it for $7 down. So just to translate, that would be $750.17 in 2026. That's assuming that that's in American dollars. So the Canadian, I'm in Canada here, so that would be $1,043.71 Canadian. So there you go. I bought it for considerably less than that, by the way. Well, as I suspected, this is completely original. Nothing's been changed out. So we'll have to replace these electrolytic filter caps here. This is a 16 microfarad, and this is a dual cap with two 10 microfarad. Unfortunately, we have these Sangamo caps here, which are not electrolytic, but are rather infamous. So we will test those for leakage, and if they're okay, then we'll leave them in. Otherwise, we'll replace them. We have a paper wax capacitor here. It's funny that there's just one that we will probably place. And in here, hiding under here, is a electrolytic cathode bypass cap that we'll have to replace as well. There's a two-prong, oh, that's the def cap. We'll get rid of that. There's a two-prong power cable that we will replace with a three-prong grounded cable. And here's the inside of the control board. This preamp little PCB board made out of wood. Yeah, so I'm going to clean these pots right now because those are very scratchy. And we'll check some of these resistor and capacitor values, make sure everything's okay. Okay, so let's take a look at the schematic. This amp uses 6 tubes, a 6x5 rectifier, 6AU6 for the tremolo oscillator, 2 6v6 power tubes, and 12AX7 tubes, one in the preamp section and a second as a preamp / phase inverter. So not surprisingly, the schematic separates the preamp slash control section from the main chassis. We have 3 inputs, 1 microphone, and 2 instruments. And the input jacks are not self-grounding, so if you're plugged into one of the instrument channels, for example, the microphone channel is still active and will introduce noise into the signal unless the volume pot's turned down. But aside from that, the input stage is very similar to the standard Fender design with 68K grid stoppers and 1 meg grid leak resistors. So the signal goes to the grid of the first 12AX7 preamp tube through a tone stack and through an RCA connector to the preamp and connecting the preamp and the power amp sections. And there it's further amplified by the first half of a second 12AX7. And then the second half of that 12AX7 is the phase inverter. So in this case, it's a cathodyne phase inverter with the plate sending an inverted signal off to the grid of one of the 6v6 power tubes, and the cathode sending a non-inverted signal to the grid of the second 6v6 tube. So in this way, the 2 tubes are out of phase, which is what you need for a push-pull configuration. And the power tubes themselves are cathode biased by this shared 220 ohm 5 watt resistor. The preamp slash control section is also connected to the main chassis through an 8-pin connector, and this carries the heater wires for that 12AX7 in the preamp, and it also connects the tremolo strength and speed potentiometers to the oscillator section. See, the oscillator, as I said, is a 6AU6 with the oscillation loop created by feeding the output of the plate back into the grid. And the phase of that plate output is changed by 3 resistor capacitor pairs. All 3 capacitors, labeled here C9, 10, and 11, are 0.02 microfarads. But the first resistor in this series is a variable 1 meg resistor that controls the tremolo speed. And then the second and the third are these R15 560K and R16 2.2 meg. So this oscillating output goes through a tremolo strength pot up here, which can send some of that output off to ground. And then the remainder goes through wire number 1 through 330K resistors connected to the grids of the 6v6 output tubes. So this modulates the bias of the power tubes, and we get that wonderful throbbing tremolo effect. And that's it. I mean, it's simple but effective. And as we might expect, the sound is going to be prone to distortion because of the cathodyne phase inverter and the cathode bias. But that's rock and roll, and that's one of the things that makes this such a great sounding amp. Well, the first thing I usually do after checking that the fuse is the correct value is I test the tubes. And all of these tubes seem to be nice and strong, so that's a good thing. Out with the old and in with the new. I ended up replacing a lot more things than I had planned to. Normally I replace the electrolytic capacitors, these filter caps here, and I guess there's also right here, there's a bypass cap. And I try to maintain as many of the original signal caps as possible. In this case, almost all of those Sangamo caps were leaking DC, and it was affecting the performance of the amplifier. In fact, the tremolo circuit wasn't working because of that. So I ended up replacing all of those caps with Mallory's, which should be much better quality. And also, while I was testing it, the 6X5 rectifier actually shorted, and it took out the fuse and it took out this resistor here, so I ended up replacing those. Thankfully, I had another 6X5 in my stash, so that was fine. We replaced the two-prong cord with a three-prong cord. And the electrolytic capacitors, this bypass cap, as I said, a few other resistors that were well out of spec. And I think we're ready to go. Let's give it a test.